I 3D printed these battery holders for my workshop, but now I've added a feature where I can actually test the battery before I remove it. I'll explain how I did it on today's Filament Friday.
This video is sponsored by PCB.
In a previous video, I showed you these battery organizers that you can hang on the wall. They're called the FIFO AA or AAA battery dispenser. They're two separate pieces that you bring together, and it's held to the wall with two screws. Then you just load the batteries in from the top. They roll down to the bottom. So the oldest batteries are down at the bottom and the newer ones at the top. And you can just pull them out one by one. I previously had these in a case where it came with a battery tester. So I wanted to see if I could incorporate a battery tester like that into the rack that I just printed. And if this requires a circuit board, I'm going to PCBWay.com. PCBWay.com is where I get my circuit boards. You can get 10 boards for $5 plus shipping. Great deal. And they also offer low-cost assembly service. You can get standard PCBs or even flexible PCBs. They got a lot of different options. And all you do is you upload your Gerber file, and then you got features like what color silkscreen or what color solder mask you want to put on it. And then it'll give you an instant quote over here on the right, just like I showed you, $10 or 10 boards for $5 plus shipping, $27 when it's shipped to me. And they also offer other services such as CNC machining, 3D printing, sheet metal fabrication, and injection molding. So you can make your own battery holders without a 3D printer just by sending it to PCBWay.com. So check them out today at PCBWay.com. The first thing I had to find was a meter to indicate whether the battery was charged or discharged, and then I could figure I could build from there. I couldn't find any, but I did find these battery testers really cheap on Amazon. I could get 2 of them for $6.99. And these things are really crude and simple. This slide is not spring-loaded. You just press it against the battery like this, and it tells you what the voltage is, whether it's good, low, or replace. And I thought this is easy enough. It's even got a mount on the side here where you can test a 9-volt battery. So I thought this is pretty good. But now let's see what's inside. So on the back, it actually shows you the range that's for good, low, and replace. I thought that was a nice feature, but I didn't need that. So there's 2 screws that hold this thing together. So I took out the first screw and then the second screw and pulled it apart to see what's inside. And to my shock, this thing is simple, very simple. There's a tiny circuit board on the bottom of the meter and then these clips with wires. That's the whole setup. So I thought, why design something when all I need is a meter? I got out a pair of calipers and just started measuring each dimension, including the window that I want to show through, which tells me the battery voltage. And what I'm going to do is build this in Tinkercad slightly bigger than all these dimensions, so then it'll just take away material from the design. So here it is. I just used a couple blocks and a half round piece, and I made the meter. Group it all together. And again, this is slightly larger than the actual meter. So I added, I think, 0.2 on each side. And then I added an extra block for the cutout of where the face of the meter actually shows through. And then I just use a block added to the battery holder and then this meter that I made to take away that space for the meter to fit into. Then I made a channel for the wire to go down to a clip. And that clip I cut out of the plastic as like a tab with 2 little slots. And that's it. I grouped it all together. And now I had in Tinkercad 1/2 of my battery holder with a gauge. And then I went and made the other side the same way. It was easy to just copy and paste. And then when you turn them 90 degrees, you'll see they're slightly different because one locks into the other. But if I slide these 2 together, I now have a box where the meter will actually sit and the wires will come down the channel to the clips. So pretty easy design. I just needed to print it. I brought the 2 halves into Prusa slicer, and I'm going to slice it at a 0.2 layer height. And I'm just going to use PLA, and I'm going to put it on the Core 1L, which is the larger Prusa Core 1. I just got that recently for the office. And once it was done slicing, this thing looked really good. And despite the added features, this is only going to take 1 hour and 49 minutes, roughly just under 2 hours to print. Not bad at all. The Prusa Core 1L is a bigger printer. It's 300 by 300 by 300, so I can print a lot of things on here, but this fits easily on the bed. And when it was done, the results are excellent. I love the way this thing prints. My other Core 1 is good too. This is a great printer series. And when you put the 2 together, it's just like I showed in Tinkercad. Looks good. For the connection to the battery, this is what I'm going to build. on the tab here that I 3D printed, I'm going to put a metal clip, and then a wire will go up the channel along the side up to the meter. And I'll cut that wire to actually fit to the meter, and I'll solder it in place. So this is one side. Now let me show you how I did this using the other side. Now for the metal clip and wire, I'm actually going to steal it from these battery holders. These are coin cell battery holders. I bought 12 of them on Amazon, and I'm not going to use them all. So I'm going to take 2 of them, and I'm going to steal parts from it. So here's how I started. This is the battery holder. It's got a little door on it where the coin cell will go into it. There's a plate for the bottom, and then there's a connection plate on the side that touches the side of the coin cell. That's the one I want. I really don't want the bottom one because it's an L shape. I want the straight one that I can bend into place. And I already stole it from the other one, so now let's take this one apart and steal it from this one. Now also, the clip that I want has a red wire connected to it. So the other one I've already installed has the red wire. So I'm also going to have to change from red to black. So I'm going to have to do some soldering here to switch this over. But once I get the cover off, you can see what's inside. It's got the side clip that I want, the bottom clip, which I don't want, and the bottom clip has a switch connected to it, and that's where the black wire that I want to steal is connected to or soldered to. So I need to get this clip out that I want to use in my battery holder. And then, like I said, I'm going to desolder this red wire and put on the black wire. I put the clip into a clamp and then use my soldering iron to desolder the red wire because I want to put a black wire on this one. So there's one red and one black. So now I need to steal the black wire from that assembly. I have that into the other clip, so I'll just use the soldering iron, heat that solder joint up, and then just pull this black wire out of here. And then now I can solder that to the clip where I just removed the red wire. So I'll go back. I actually added a little bit of solder to the clip here, but I'll put the black wire in place. Now I'm ready to install this into the other half of the battery holder with the battery tester. I flattened it out and then shoved it into the first hole, and I bent it down to see at what point I need to bend the other end of it to go into the bottom slot. So once I knew where that was, I pulled this thing back out, and then I could bend it into the 90 degrees so it fits in the bottom slot. From there, I just fed it into that top slot, and it was a little tricky at first, but once I got it in, then this thing lines up with the bottom slot, and then all I had to do was bend the tab, or the little bit that's poking through, to hold it in place. So it's pretty easy to bend, so I just bent it with my fingers, but then I used the pliers to make it even tighter, and then flattened everything out from there, and we've got our battery clip with the black wire. So now I just need to route the wire up the channel, and now I've got the other side pretty much built. So a little bit of wire will be exposed even after I put it up the channel here, but that's okay because then I'll know which side is negative black and which side is positive red without any indicators. The slot's a little tight. You can push something really thin in to push the wire in deeper, but then I pulled it from the top and then figured out the length, and then I cut the red wire and then use a stripper to just strip the end of it because I'm going to solder this actually to the meter. And then I had to do the same thing to the other side, the black one. So I cut it to the same length and then strip the end of that, and then I'll have my 2 wires that I can solder right to the meter. I put the meter in my 3D printed vise, and this first wire for the 9-volt battery, I didn't need that, so I just took that off. But now I'm going to do one wire at a time so I don't screw this up. So this is the one side of the battery tester, the red wire. So I brought the red wire half of my battery holder in and soldered that in place. Now I'm going to do the other side, the black wire. So this way I don't mess anything up. I'm getting the connections at the right point. So I desoldered the black wire and then put my new black wire, my new clip in place. And if you notice, the solder loosened on the meter. I did fix that. I soldered it back in place before I assembled it. But I wanted to test it, so I brought a battery in to make sure all my connections were working. And sure enough, when I press it to the sides, it shows the battery is good. So now I can assemble this thing and turn it into the battery tester and holder that I want it to be. I got the dimensions right on the meter. This thing fits in perfectly. I just have to make sure the circuit board is pushed up and then held in place, and then get the wires into position so they tuck away into the sides. And once I got that together, this thing was ready to install. And you can see the black wire and the red wire hanging out down by the tabs, so I know which way to put the batteries in. And now I can test it right here on the bench, and it's working every time. Those tabs that I made flex just enough to touch the battery, but the battery has gaps on both sides, so it doesn't touch until you press it. So now I just needed to install this in place of the AAA battery holder that I had before. It just takes 2 screws, and this holds the 2 halves together. So once those are screwed into the wall, this thing's ready to load batteries. So I loaded it up, and now I can test the battery before I remove it and know it's good. If it's bad, I can throw it out. If it's good, I can use it. The next step is to redesign the AA side. It's a little bit wider, so it's going to take some adjustments, but I can easily do that in Tinkercad. So what do you guys think of this? This is a good idea, bad idea? You want to build it? Let me know in the comments below. I want to give a big thank you to all my Patreon supporters, including the new people who have joined us. Thank you for all your support. Thanks for watching. And here's a few other videos you might like. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that logo and subscribe. I'll see you next time right here at Chuck Hollenbach's Electronic Products and Filament Friday.